I'm just going to go through interpolation relating to longitudinal stability. Often with longitudinal stability we have to pick maybe 4 values from our hydrostatic particulars that we've just got here, and they're generally going to be our longitudinal centre of flotation, our centre of buoyancy, MCTC whether in salt or fresh water, displacement and draft. So these are all the values that are required from the hydrostatics. Of course, if our draft, for example, was simply 9.4, very straightforward, we just go along the line, pick all the values off. Similarly, if we knew our exact displacement, again we can just simply go along the line and pick everything off. But you will find in problems at times that your final displacement does not fit an exact figure on the tables. So what I've done, I've made up a figure, and we're going to look at what I consider a reasonably straightforward way to interpolate. There's no absolute definite only way to interpolate. There are 1 or 2 different ways. I'm just going to show you the way that I personally find reasonably straightforward. So what we're going to say is that our final displacement in salt water is 16,310 tonnes. So if we go to the table and we look for 16,310, we can see it rests between 16,212, 16,448. So we can't pick the exact value from the tables, we need to interpolate. So what I've done, I've written these 2 displacements down either side, I've written the 2 drafts either side, the MCTs either side, LCBs and LCFs. So if we have a look at the values here, I've written them down. Our final displacement was 16,310, and I've put it there in green, 16,310. And I've written the values that fall either side. Draft was 7.7, 7.8, MCTC, LCB, LCF. Of course, the final values must fall exactly between these values here. What I do, I compare the 2 displacements from the hydrostatic tables and get the difference. 16,212 from 16,448 is 236. Now I interpolate from this one upwards. You could interpolate down, that's another way, but I'm going to interpolate from 16,212 towards 16,310. And that means when I get my proportion of these values here, I must apply them this way. I apply them the same way as I do the interpolation. So 16,212 to 16,310, that value there goes on top, 98 over 236. Then I get the difference between our 4 values, which I've put in green there, 0.1, 1.4, 0.05 and 0.1. So you can see there, they're the differences as we look at the values. Then 98 over 236 on your calculator will give you 0.415. All I then do is multiply 0.415 by 0.1, 0.415 by 1.4, 0.415 by 0.05 and 0.415 by 0.1. And then I get my proportions there, 0.04, 2 I've called it, 0.58, 0.02, 0.042. I then apply these corrections that way. So for draft, it's going to be 7.7 plus 0.042 will give me 7.742. MCTC will be 195.4 plus, I've called that 0.6, I've rounded it, and that comes to 196, falls between the 2 values. For the LCB, it's the 69.72. Now if you've got to be careful because that's minus, you can see that the LCB is going less. So it's 69.72 minus the 0.02, 69.7. Similarly with LCF, 66.61 towards 66.51, we must minus the value, and that gives us 66.57. So as a final check, you can always look at the answers you've got and ensure that they do fall exactly between the values that we picked from the hydrostatic particulars. That's how I do the interpolation. As I say, there's different ways. I just find that quite straightforward. Get my initial value with the calculator, 0.415, and simply multiply that through. And that's, I think, a fairly straightforward way to do interpolation.